What's up, you freaking geniuses? So, in this video, I'm going to teach you how to identify prime and composite numbers. Okay, so when we talk about prime and composite numbers, we're only talking about natural numbers, okay? Or sometimes they're referred to as counting numbers, okay? So they are basically just whole positive numbers, right? So like 1, 2, 3, 4, right? And we could keep going. So we're not talking about decimals and we're not talking about negative numbers, okay? And we're also not including zero in this, right? Because zero is not a natural or counting number. Okay, so with that in mind, let's break down the differences between prime and composite numbers. So first of all, prime numbers. We'll start with prime numbers. What are prime numbers? So prime numbers are numbers that have exactly two factors, okay? They don't have one factor, they don't have three factors, they have exactly two factors. And what are those factors? It's always going to be the number 1 and the number itself. Okay, so let me give you a few examples of prime numbers. So, for example, we have the number 2. Why is 2 a prime number? Because it has exactly two factors. There's only two numbers we can multiply together to get the number 2. Those numbers are 1 and itself, right? The number 2, because that gives us 2, right? So, what are the factors of 2? 1 and 2, right? 1 and 2. Another example of a prime number would be the number 3. Why is 3 a prime number? Because there's only two numbers we can multiply together to get the number 3. 1 and 3. Okay, that gives us 3. So what are the factors of 3? 1 and itself, right? So the factors are 1 and 3. Another example would be the number 5. Why is 5 a prime number? Because it only has two factors. 1 and itself, right? Only 1 times 5 gives us 5. There's no other numbers we can multiply together to get 5. So what are the factors of 5? 1 and itself, right? 1 and 5. Okay, and we could keep listing more, and you would see that the number 7 is prime, the number 11 is prime, but I think you get the gist of it, right? So prime numbers have exactly two factors. 1 and itself, right? 1 and itself. 1 and itself. Okay, and one other way you can think of prime numbers is that prime numbers are only divisible by 1 and itself. Okay, so the number 2 is only divisible by 1 and itself. The number 3 is only divisible by the number 1 and 3, right? The number 5 is only divisible by the number 1 and 5. Okay, so those are two different ways you can think of prime numbers, but they're always just going to have two factors. Okay, so now with that in mind, let's move on to composite numbers. So what are composite numbers? Okay, so composite numbers are kind of the opposite of prime numbers. Prime numbers have exactly two factors, so composite numbers have more than two factors. Two factors. Or another way we could say this is that composite numbers have 3 or more factors. Okay, so let me give you a few examples of composite numbers. So the number 4 is composite. Why is the number 4 composite? Well, what numbers can we multiply together to get the number 4? Well, we can always start here. Okay, we can always multiply 1 and the number itself. So let's do that. So we can always multiply 1 and the number itself, right? That will give us 4. Okay, but what other numbers can we multiply together to get 4? Well, we could also do 2 times 2, right? That gives us 4. Okay, so how many different factors does the number 4 have? Well, let's see. We have 1, we have 4, and we have 2. Okay, so let's list those out real quick. So we have 1, we have 2, and we have 4. So how many different factors does the number 4 have? 3 different factors, 1, 2, and 4. Okay, another example of a composite number would be the number 6. Why is the number 6 composite? Well, what numbers can we multiply together to get 6? Well, again, we can always start here, right? We can always multiply the number 1 and itself together. So let's do that. We can always do 1 times itself. So 1 times 6 equals 6. Okay, but what other numbers can we multiply together to get 6? Well, we could also multiply 2 times 3, right? That gives us 6. Okay, so how many different factors does the number 6 have? Well, we have 1, 2, 3, and 6, right? 1, 2, 3, and 6. Okay, so we have 4 factors here, right? 4 different factors. So the number 6 is composite. And let's do one more. Okay, what about the number 8? Why is 8 composite? Well, what numbers can we multiply together to get 8? Well, again, we can always start with 1 and itself, right? So 1 times 8 is equal to 8. All right, but what other numbers can we multiply together to get 8? Well, we could also do 2 times 4, right? That gives us 8. Okay, so how many different factors does the number 8 have? It has 1, 2, 4, and 8. 1, 2, 4, and 8, right? So we have 4 different factors for the number 8. All right, guys, so now you know the basic differences between prime and composite numbers. So now let's try some slightly more difficult examples. Okay, so let's start with this one. Let's do the number 1. Okay, so is the number 1 prime or composite? Well, the number 1 is actually neither. Okay, why is it neither prime nor composite? Well, let's see. What numbers can we multiply together to get the number 1? The only numbers we can multiply together are 1 times 1, right? That gives us 1. Okay, so how many different factors does the number 1 have? It just has this one, right? It just has the number 1. Okay, so prime numbers have exactly 2 factors, right? Composite numbers have 3 or more factors. Okay, so since the number 1 only has a single factor, it doesn't fit our definition for prime numbers or for composite numbers. Okay, so that's why it is neither prime nor composite. It's just its own special little snowflake. Okay, so that's how you deal with the number 1. Let's try another example. Is 29 prime or composite? What numbers can we multiply together to get 29? Well, we can always start with the number 1 and itself, right? 1 times 29 will give us 29. Are there any other numbers we can multiply together to get 29? The answer to that would be no. So, is 29 prime or composite? Well, it would be prime, because the only 2 factors it has are 1 and itself. What about the number 33? Is 33 prime or composite? Well, again, we can always start with 1 and itself, right? So 1 times 33 gives us 33. Are there any other numbers we can multiply together to get 33? Well, we could also multiply 3 times 11, right? 3 times 11 also gives us 33, right? So is the number 33 prime or composite? Well, it would be composite, because it has 3 or more factors. What are the factors? Well, we have 1, we have 3, we have 11, and 33, right? So the factors are 1, 3, 11, and 33. Okay, what about the number 57? Is 57 prime or composite? Well, let's see. We can multiply 1 times 57 to get 57. Are there any other numbers we can multiply together to get 57? Or another way I can ask that is by saying, are there any numbers we can divide evenly into 57? Well, let's see. Is 57 divisible by 2? No, because this is an odd number, right? It's not an even number. Is it divisible by 3? Well, let's check. Let's use our divisibility rule for 3's. Okay, so if you want to see if a number is divisible by 3, just add up the digits and see if that's divisible by 3. Okay, so we're going to add up these digits right here. 5 plus 7. What's that equal to? 12. Okay, is 12 divisible by 3? Yes, right? 3 fits into 12 evenly 4 times. So that means 3 also fits into 57 evenly. So we know 3 times something is equal to 57. Okay, so is the number 57 prime or composite? Well, we can already figure it out, okay? Because you need to remember, what's the definition for composite numbers? Composite numbers have 3 or more factors, right? So how many factors do we have here for 57? Well, we found 1, 2, 3 of them, right? So I don't even have to check this number because we already found at least 3. So that means 57 is composite. Okay, but just in case you do want to figure out what this factor is, you could just divide this number and this number. Okay, so you could just figure out how many times 3 goes into 57. And you would find that it goes into 57 exactly 19 times. Okay, so 3 times 19 is equal to 57. All right, guys, so that's how you identify prime and composite numbers. I hope it was helpful. If it was, definitely leave a thumbs up down below. It's always appreciated. And if you still got any other questions, leave them in the comment section below, and I'll do my best to try and help you out. There's a whole pre-algebra playlist attached at the end of the video, so if there's any other topics you want to check out, definitely check them out, and I'll see you there.